Good morning, everyone, again. I hope you are enjoying this summit. I'm here to present the challenge that we face as a transmission system operator to the sustainable transitions. So, the agenda of my presentation is this. The REN brief overview of the group, of the business, energy transitions, and then we look the integration of renewables, where you are and where you go, the security of supply and system operator, some real examples that we have, and the grid development, the grid, what you need to do to integrate this amount of renewables that we can see, can forecast for the next years, electric mobility that we need, and the studies that we are done in this topic, and of course, I cannot come here speak about energy without speaking about hydrogen. And final, some remarks about the challenge that the future. Brief overview of REN. What are you doing? You are an integrated network operator in Portugal, focused in three main areas: electricity transmission system, gas transmission system, LNG terminal and underground storage operator, and gas distribution system in the north of Portugal. Some main figures that we have in the electricity transmission. More than 9,000 of kilometers of red lines and almost 40,000 of MVA of transformers. If you look at the gas transmission system, you have 1.4 thousand of kilometers of pipelines, one LNG terminal in Sines, and 6 underground storage. And if you look at the gas distribution system, you are more than 5,000 of kilometers of pipelines, and we supply 7 terawatt-hours of consumption. International business, you are 42% of the company Electrogas that operate in pipelines in Chile, and we have 100% of the TransML company that operated in transmission lines and substation in Chile too. So after this, integration of renewables. First of all, we need to look what we are here today, how we are. If you look the integration of renewables in the gross final energy consumption, we are in the top 10. And if you look the renewables, the integration of renewables in the electricity production, we are in the top 5. This is what we are. So Portugal is one of the leaders of integration of renewables in the European countries. And of course, with this, you decrease the CO2 emissions year by year. So now, looking the mix installation in Portugal. We are 20 gigawatts of generation installation in Portugal. Consider the last installation of hydro pump storage in the north of Portugal this year. And it represents the double of the peak demand in Portugal. If you look the separate values, we have in hydro, you have 8 gigawatts of power plant installed. Wind, we have more than 5 gigawatts, and solar is starting now to increase. In the end of 2021, you are only 1.4 gigawatts of solar. And if you look the non-renewable energy, you have the CGTs, the natural gas. You have 4 gigawatts of installation in Portugal. So the installations of CGTs it's these Ribatejo power plants, Pego, Lares, and Tapado do Boteiro. If you look the large installation of hydro, it's here, but the most it's here in the north of Portugal. If you look these figures of Portugal today, you need to look the dispatchable and non-dispatchable generation. You have now 60% of dispatchable generation and 40% of non-dispatchable. Please save these numbers because it's important to look these numbers and foresee the future what it's happening. So, looking these graphics, especially this one, the demand supply mix. what you can see that year by year, the energy wind is more or less stable and represent 25% of the consumption in Portugal. However, the hydro is not the same, because the hydro depends if the year is wet or is dry. So how we can face these situations? With more importations or more CGT working with natural gas. So now, looking the future, what do you see? You see the evolution, the installed capacity evolution. In 2013, we disconnect the last full power plant, and in 2021, we closed the coal power plants. Now, future, what you can see, a big amount, very big amount of new installations of renewables. 15 gigawatts of new power plants, solar and wind, for the next 8 years. How you can do this? If you look the values that we have in solar in the first slides, it represents 5 to 6 more than the actual installation in solar. And the wind is almost 2 times more than the actual installation. So what you can see, that if you remember the numbers that I told you before, we represent that this possible generation, it's only represent 30% compared with the past that we have 60%. Now, look some figures that we made some calculations about what we have in 2030. With this evolution of the installed capacity in Portugal, we have 95% of renewables in the mixed generation in Portugal in 2030, and in 2040 you have 100% of renewables in Portugal. So, come back a little. As you can see, with these big numbers, we need to do a lot in the next years in Portugal. Now use the numbers that I showed you before and compare Portugal with Spain and Germany. Look only for the solar. This increase and compare with the peak load, it represents 140% the peak load in Portugal. So what you can see, and it's compared with other countries, Portugal is the biggest. So in 2030, we expected that renewable energy output in Portugal will frequently exceed the peak demand in Portugal. So, security supply. If you have a lot of these, how you can do the security supply and the system operator? I can present some real cases that you faced in the past. This is the hydro evolution during the year, wind and solar. Use the example of wind. What you can see that typically we have ramps increase and decrease, variation of production of wind. Typically we have variations of 1 gigawatt, and we expect in the future 3 gigawatts of variations. So ramps increase and decrease very fast in Portugal. How we can deal with this? Flexibility. We need more flexibility in the systems. We need more investments in the grid. We need cooperation between the transmission system operator and distribution system operation. We need to work closely. And, of course, digitalization. It's needed to digitalization, to more information to work in this field. So, flexibility is an essential requirement for the energy transition. Why? Because you have new stakeholders in the balanced market. Small generators, small consumers. Balanced markets participate for the newcomers. European balanced platforms will introduce cross-border competitions and mandatory observability and controllability. It's really necessary to work the operation of the system. Can I give you another example to show the cooperation that we need to have in between the transmission system operator and the distribution system operator. This is one example. We have several examples of this. This substation we have most of the hours the flows coming from the distribution to the transmission system, because we have a lot of installation of PV power plants and wind in the distribution system. So, real cases. This one, when you have a lot of wind production, we are pumping in the system, because we have a lot of, we have 4 gigawatts of pumping storage in Portugal. We're pumping in these hours when you have a lot of wind, and after that, when the wind decreases, in the same hours, we have peak demand. What you have all the hydro generate energy and help Spain with exporting to Spain. Another example, the ramps that I spoke the first slides. Here and here, big ramps decrease 80% in 4 hours, or 100% in 8 hours. How can face this problem? With pumping and generate by the hydro. This is an example, and of course export, because we are really interconnected with Spain. And final, an example that we have more than 4 days that our renewables can supply our demand, and we export to Spain. So now, grid development. What you need, what we are doing the next years. First of all, we need to talk a little about the 3 alternative ways to give permission to install power plants in Portugal. As you know very well, general access, auctions, and direct agreements. The first one, in Portugal, namely in the transmission system, we don't have more capacity, because it's only used when you have capacity in the system, and together with the 2 operators and the general director of energy, we work together to give these permissions. Now, in the transmission system, don't have capacity. We are working with the new legislation to create more capacity. Auctions. When the government decided to launch the new tender, you work together with the government in order to create the conditions to have new tender. You already read in the newspapers that next year we have another tender with offshore wind and direct agreements. We have a lot of requests, as you can see here, in the past. After that, the General Director of Energy published the 2 lists, one from the distribution system and another one for the transmission system. And now the 2 operators are studying in the first step of these projects to make the agreements between the operators and the promoters. Next, so what we can see here, what REN now doing, we have more than 70 new connections in the next years, next 3-4 years in the transmission system. This is a big amount. We never have this situation. PV power plants, it's 55 of PV power plants new that are connected in the transmission system. If you look the Portuguese map, you can see that almost the PV power plants are installed in the south. So you need to transport the energy from the south to the north. And what we need for this? Reinforcements. This is the reinforcement that we have to do, the REN need to do for the next 4 years. It's a lot of reinforcements. If you look, some figures here, we have more than 1.6 thousand of kilometers of new reinforcements. It's a big number. It represents 17% more than the existing grid in Portugal. We have 300 kilometers of operating lines. We need to create 6 new substations. Represent more 7%. You have to create 3.3 thousand of MVA transformers, which represent 8% that actual existing transformers. So, in order to understand what is the problem and what you need to do the next 4 or 5 years, compare with this. This is the numbers that we are, did in the last 5 years. Lines. We built 600 kilometers of lines in the last 5 years. Compare with this. Three times more. It's what we need to do in the next 4 years. So, the last slide about this topic, the rule of the interconnections. Portugal and Spain are really interconnected. You have 9 interconnections, and the capacity interconnected is around 3 gigawatts of power, so we are really connected. So it permits that we have no market splitted. So the interconnection is really important for the Portuguese system because you increase the security of supply and the market integration and avoid spillage energy, typical renewables. So what we are doing in the electric mobility. This is the studies that we are done, impact of electrical vehicles in the final electricity consumptions. Today, the electric vehicle don't have impact of the consumption. But in 2030, we expect between 4 and 7% of the total consumption. In 2040, it's between 8 and 14%. So, if you look these figures and look the impact of the peak demand hours, you can see that we have between 800 megawatts until 1,600 megawatts of the impact in the final in the peak demand consumption. So, what did the electric vehicle can support the system operator? Of course, this is some figures that you know very well in some presentations. It's not from REN. But what you can see that not today, but tomorrow the electrical vehicle can support the system operator. Why? Because I think the future will be here, and spinning reserve, grid regulation, peak shaving and load leveling, reactive power compensation, and renewable energy support will be an opportunity for the electrical vehicles. So, to finalize this topic, what REN are preparing the future? We developed the speedy fast power. It's the electrical mobility with an unlimited power. You can find more information in this link. What you are? You have a solution and a business model developing the REN, developed by REN to supporting the decarbonization and the transport sector directed by the existing overhead lines. Final, speak about hydrogen, what we are doing about the hydrogen. Hydrogen promotes integration of sectors. REN has a special position in these sectors because you work in the electricity and in the gas. Infrastructures are relevant to accelerate the decarbonization, and asset sustainable is a basic condition for the quality of security of supply. So, what is the REN agenda? Accelerate the grid development for the renewable integration. We cannot have hydrogen with less prices if you don't have renewables. So we are doing this work. Adapt the actual transmission, storage and distribution infrastructures in order to accommodate blends. You are test the equipment to do this. Develop and optimize the infrastructures to interconnect hydrogen producers and consumers. We are doing this now in Sines. Increase the actual gas infrastructures to receive green hydrogen. Optimize the infrastructures costs to receive renewables and hydrogen, and minimize the impact of the assets. So, last but not least, ensure the adequate supervision of the control, the system, gas system, and 100% of green hydrogen infrastructures, and assuring the quality control of the consumers. So, to finalize my presentation, I think you don't have too much time. The main remarks about what we are facing the next years. New models for the network plans needed. We are preparing these, we are developing some new models to simulate the network planning. New challenges for the network and system management appear, and you are preparing the system to deal with this. Security of supply is more relevant with more renewables installed in Portugal, and you are prepared the system to do this. You have studied and we have prepared the operation system to do this. Facilitate and promote the connection between the renewables and the large demands. You are working with this to connect the consumers, the big consumers, and the PV power plants and wind power plants. And of course, storage will be relevant to balance between the renewables and the demand and avoid spillage, the energy spillage. Well, electric mobility must be analyzed in order to consider the role of the grid. As I said before, it's really can be a vector that can be analyzed in the future. And final, hydrogen and renewable gases will launch challenges for the gas infrastructures, but also the electricity infrastructures. Thank you very much. I'm trying to be very fast because we are late. I'm available some questions or not. I can speak with someone in the lunch.
It was really good to shift from discussion about business opportunities and the need for decentralization and all of the nice things that are helping people define their role in that ecosystem to the actual challenge of delivering national infrastructure and providing the means of enabling new stakeholders to participate in the energy markets, which is going to be the topic of our next panel discussion, I think, among other things. So you covered an awful lot of ground, but it shows really how you're operating on a long-term horizon, anticipating the needs of each new market as it evolves. The latter point about e-vehicles and hydrogen were particularly well made because they're kind of nascent, hydrogen particularly so, but in 10 years you're already anticipating that there'll be sufficient momentum to really make an impact on your network. Do we have questions from the infrastructure side? Yes. 2/3 of the way up.
Hello, Bruno, thank you for the presentation. It was quite interesting. I'm Thomas Jordan from CleanWatts. And my question is, so you showed that we are good with the storage in the hydropower right now. But my question is, in the future, do you see the storage in the hydropower as enough? Or is hydrogen and vehicle to grid specifically as a necessity or just an option?
Really, I think it's a necessity. If you look the figures, we need to have renewables and you have a big amount of renewables installed, but you need to have some storage to save this energy and the type of spillage. So I think it's a very peninsula need storage. It's clear. More hydro pump storage or batteries or hydrogen, I think will be the future. You need, because if not, you cannot save the renewables that, for example, the solar, you know very well where is the time that you have production. So yes, the answer is yes, you need more storage.